In this video, we're going to look at areas between curves. The motivation here is we're going to extend the application of definite integrals to represent areas between curves. So let's look at some definitions. The area of the region bounded by the graphs of y equals f of x and y equals g of x, where f of x and g of x are continuous, and f of x is larger or equal to g of x for all x in the interval ab, is given by the definite integral a is equal to integral a to b f of x, which is the top function, minus the bottom function g of x. This integral is going to be a positive quantity. If you get a negative answer, it means you did something wrong, because area is always positive. Now, for the general case, I should say for the special case, g of x is equal to 0, a is equal to integral from a to b f of x minus g of x, which is just 0. So f of x dx. This is the area bounded by f of x and the x-axis. All right, for the case where f of x and g of x are both positive, then the area is defined as the area under f of x, the area under the top function, minus the area under the bottom function. And in terms of an integral, we write this as a is equal to integral a to b f of x dx minus integral a to b g of x dx. Now, we know that the difference of integrals is integrals of a difference. So we can write it in a more compact notation and write this as integral a to b f of x minus g of x dx. We have a drawing here that illustrates what's going on. And you can see that the height, this height, is basically f of x minus g of x. And this is dx. dx is the width. So what we have is the area, dA. That's the area of this slice here. So dA is equal to f of x minus g of x dx. Essentially height times width. So dA is equal to f of x minus g of x dx. Now the area of the region is going to be the integral from a to b, and we add up all the rectangular slices. Integral dA. That's integral a to b f of x minus g of x dx. All right, so let's look at the question. Here we have find the area of the region bounded by the graphs of y equals 1 over x is equal to 1, x is equal to e, and the x-axis, which is just y equals 0. So what are the steps? Sketch the region, that's the first step. Determine the limits of integration a and b. Number 3 is set up the definite integral a to b f of x minus g of x dx. And number 4 is solve the integral, integrate. All right, let's do that. So what we have is, we have the drawing here, y is equal to 1 over x is equal to 1, x is equal to e, and the x-axis, y equals 0. We have the formula, area is equal to integral a to b, y top minus y bottom dx. So basically, subtract off the bottom function from the top function, integrate, and we get the area under the curve. And the differential area is going to be height times width, that's 1 over x times dx. All right, so the area is going to be integral from a to b, that's from 1 to e, top function, which is 1 over x, that's y top, minus bottom function, which is 0. So 1 over x, this is y top, and 0 is y bottom, and integrate with respect to x. So we have integral from 1 to e, 1 over x dx. What is the antiderivative of 1 over x? What is the function whose derivative is 1 over x? Well, that's log x, because when you differentiate log x, you get 1 over x. Applying fundamental theorem of calculus from 1 to e, and we get log of e minus log of 1. What is log of e? Log of e is 1. Make sure you memorize that. Log of 1 is 0. So the answer is 1 minus 0 is equal to 1. So the whole area is going to be equal to integral from 1 to e, 1 over x dx, and we computed this area to be 1. And this is essentially this shaded area. This shaded area is 1. All right, thank you.